Okay. All right, let's look at a quick example here. How about? So let's go through the process of making the table. Seems like that's something maybe people are still not quite 100% confident in learning. I know some people are probably getting close to having this assignment done, but humor me and let's go through one more of these. So remember our table. Table's we're gonna have 3 columns. We've got the vector column. We've got the x component. We've got the y component, right? And then we got to take each of these vectors individually and break it into components. Okay, so first one. What do we got the first one here? South of west. So when we make our XY coordinate system, we're going to be, where's that going to be? If I'm south of west, south. So I start west, right, and I rotate south. Okay, so vector 1 is going to be our blue vector. There it is, right? There's the information. So that's going to be vector B, I guess. I don't know, B for both. And so it's at 34 degrees. It doesn't have to be exact. There's our representative vector. Got a magnitude of 4.62. And let's see. This is our angle. That's a point. Here's our angle. It's 34 degrees, 0.0. That won't write 0.0. And we got to break that into components, right? So see if you can just think about this for a second. See if you can tell me what the magnitudes are going to be of the two vectors. I want to probably draw them in. If this is my angle, then I have to include the angle, right? So I have to make that my horizontal component and that my vertical component. What is B sub x going to be? Negative. It's going to be negative, okay? Which trig function is it going to use? Cosine, right? Because we're going to multiply the magnitude of the vector to make it smaller by cosine because it's adjacent to the angle, and cosine goes with adjacent. If you forget why that is, just write out. So cosine goes with adjacent, right? Okay. And we know we're always using either sine or cosine for our components. Okay, so we have two choices here. We could write negative 4.62 sine of 34 degrees, or what's our other option? Well, we're in degrees, but remember I don't even have to include the sine if I just take the whole angle from 0, right? Remember our trick? So either or, we're going to get the same answer. Or I could just say positive 4.62 times the sine of the whole angle, which would be what? Okay, good. 180 plus 34, so 214. Okay. We get the same answer either way. It doesn't matter. Okay. And so then, what's the sine going to be? I mean, the y component. Sine. Yep. So we're going to get 4. Either negative 4.62 sine of the small angle, right, because of its orientation. Or I could just ignore the sine, the SIGN sign, right, and multiply by the SIN sign of the whole angle. Oops, 214. Right?
Why are they both sides?
Oh, hang on. Oh, you're right. You're right. This should be, right, so this should be, the other thing we got to remember that's a little tricky about this, it's easy to forget, is that this is supposed to be cosine, right? If you're going to do the whole angle, the x component is always going to be cosine, right? And that was supposed to be cosine anyway, wasn't it? Right, we said cosine there. You told me cosine. For some reason I wrote down sine.
So
And if you're doing the whole angle, it's always cosine for x, regardless of where you make the little angles, right? Okay? Don't do them both, just pick one or the other, doesn't make any difference. Okay?
Does it make a difference when you add them up?
No, because the cosine of 214 degrees is gonna be the very same thing as the cosine of 34 degrees times -1. Guaranteed. Yeah. So if you use the whole angle, it's gonna give you back the correct sign for that component.
Would it be the same thing either way, just not including the sign?
Say it again?
Would it be the same thing either way without looking at whether it's positive or negative?
Well, okay, I'm not sure what if the question is, does it matter if I put the negative sign there?
No,
Yes.
like whether or not you put depending on the signs, if you just don't look at those either way, then it doesn't really matter if you put 214 or 34, right?
No, it does, because if you're gonna put 34, that means you're using a reference triangle. That means we're using a right triangle that's placed in quadrant 3, and so then I need to put the signs associated with the directions of the vectors. See, this is actually a negative component, right? So when all's said and done, the number that I calculate here has to be negative, because the x component of this vector is pointing backwards, right? I'm gonna get a negative answer doing either one of these two things. Either by just, and like I said, I mean, whichever one you prefer to do is fine. It doesn't make any difference. I like to do it this way, because I feel like when you're on the calculator, then you never have to you have to worry about changing the signs in front of the trig functions. But it's totally up to you. It doesn't make any difference. Right? That make sense? Okay. So then, how about the next one? Next one is we've got a current that flows southwest at 3.4 meters per second. So southwest, so then we're gonna get same kind of a picture almost. Right, so it's going 45-degree angle. Okay, I'll go ahead and I want to make this one the 45 this time, so I want to illustrate something. So if we make that the angle, then my components have to be there, and the magnitude is 3.54. So we'll call this one, the green one, what do we call that, C for current? So C sub x then, if I base it on my reference triangle, there's C sub x, am I going to multiply by sine or cosine?
Sine.
There's the angle, it's opposite, right? So I'd go sine. Now, what's the sign gonna be? The SIGN sign, positive or negative? Negative. Okay, so we'd have either negative 3.54 sine 45 and negative 3.54 cosine, right, for the y component. Everybody see? Right? Or I can just not attach a negative or a positive sign to the thing and do the whole angle, okay? But this time, the whole angle is gonna go from there, right? What's that gonna be? 225, so 180 plus another 45, right? And so we're gonna get then positive 3.54, what trig function am I gonna use? Gotta use cosine. You don't have a choice. If you're using the whole angle, it's always cosine for x. And the way you remember it, if you're not sure, is just imagine, just think about what if you had a simple angle in quadrant 1. Because it's gotta be the same for everything, so pick an easy one to kind of jog your memory or test the situation out, right? If I had a simple angle up here, like that, and that's theta, well then isn't that gonna be a cosine for x and sine for y? See what I'm saying? You can always just kind of remind yourself that one. Like a simple example in quadrant 1. And then last one, We got, Scooter goes 6.78 meters per second, 34 degrees north of west. So that one's gonna be, what if I just use this same, what if I just use this guy being as that's a quadrant we're not using anyway, right? So, third one is 34 degrees north of west, so I start at west and tilt north, right? 34 degrees, 6.78. So my reference triangle is going to go like this, right? So what's my x component going to be then? Positive or negative if I'm using the reference triangle? It's got to be negative. So we called this one, what did we call this last time? P or S for Scooter? So I'm going to get negative 6.78. Sine or cosine? Cosine? Everybody agree? My x component?
Good job, Rick.
Cosine 34. And then the y component, positive or negative? Positive. The y component's pointing up, so that's positive. So this is going to be 6.78 sine 34. Or if I use the whole angle, I would just have positive 6.78. What's the angle going to be this time? If I do the whole angle. How am I going to find it? 180 minus 34. Good. So what is that? 146. Okay, good. So it's got to be cosine. Because we're only going to go, this time we're only going that far. How far did we go? Well, we went 34 degrees short of 180, right? Or we think about going 180 and then backing off by 34, okay? 6.78 sine 146. And now we just put all that stuff in our calculator. And we're going to get a result, right? So, and you'll see here why it's easier. It's not a huge deal, but you'll see it's a little easier to do this using the whole angles. Okay, so we can just go, what are we going to get here? So I'm going to use the whole angle, so I've got 4.62 cosine 214 plus, notice they're all cosines and they're all positive. It makes it a little bit easy, doesn't it? So if I'm finding the x component, plus 3.54 cosine 225 plus 6.78 cosine 146. Okay, enter. There's our x component of the resultant, right? Oh, I lost it. So I'm going to write down the decimal, but remember, we won't use the decimal. We're going to use the unrounded number on the calculator. So our resultant, r sub x, negative 11.95, blah, blah, blah. Okay? Scoot over to the y component. Check out how easy this is. All I've got to do is change all the cosines to sines. So second left scoots me all the way over. Make that a sine. See the advantage of this? Make that a sine. Oops. Make that a sine. Hit enter. And there it is. So roughly negative 1.295, blah, blah, blah. So then now we can build our resultant triangle just from those components, right? So if we scoot down. The x component, we're going out this way. Negative 11.95, blah, blah, blah. We're going to go down by negative 1.3-ish. And then there's the resultant. So we'll just take the Pythagorean theorem of those numbers, right? Everybody see? Okay, so we just go square root of, put in parentheses so we can square it, that number in parentheses, so we get a positive answer, squared, plus in parentheses, everybody knows why I'm putting the parentheses there? Right, because remember, if we square a negative, it's got to be in parentheses. That number squared. So there's the magnitude, right? And then to find the angle, I'm going to call this my angle theta, right, for the reference triangle. And I'm just going to do the arctangent of opposite over adjacent, right? Once again, I got to make them positive. So, say it again.
Then why do you find the 12?
That's the length. That's the magnitude of the vector. Right, so we need to know magnitude and direction, both parts of the vector. So there's the magnitude. Then we'll do second tangent of how do I, oops, didn't mean to do that. How do I make that answer positive?
Hocus pocus.
Hocus pocus. It's kind of mathematical hocus pocus. How do I make any number positive?
Times by -1.
Okay, but what if it's already positive?
So then times by 1.
Okay, there's a function that does that for me.
Could you go?
What is it? No. Absolute value, yeah.
That's what I see.
Okay, absolute value. So here's an easy way to get to it. All you do is hit math, scoot over to number, and it's your first option, ABS. Okay?
That's what I was going to say, but I wanted to.
So absolute value, notice it gives me the absolute value bars of the opposite, which is the small decimal, so that guy. Get out of the absolute value bars. Divided by absolute value, so math, number.
Why can't you just take away the negative?
Well, how do I, that's what I'm doing. That's what absolute values do.
You can't just go take away the negative.
You can just go and manually.
Oh, I guess I could do that too, couldn't I? Yeah, I could, you're right.
Okay.
Yeah, that's fine. So let's do that that's a good idea. I could. So I could just divide by this guy. And then just go back. Oops. Did I mess that up?
You goofed it.
Oh, I really goofed it, didn't I?
Done goofed.
Man, I did. Clear. Gosh. Arctangent of that number. Make it positive. So I like it. That's an efficient strategy. Whoops, we'll just go over, delete that negative sign. Second right arrow gets me all the way over, divided by that guy. Scoot all the way over, take that negative sign away. Second right, close it, boom. 6.18, okay?
It's a really slight angle.
So it is a pretty small angle, but it kind of should be. You can see that, right? I didn't draw it to scale. But it's a pretty small vertical component compared to the horizontal, so it kind of makes sense. So then let's interpret this for our answer. Okay, let's put the answer in. So we're supposed to enter the magnitude rounded to how many sig figs?
3.
3. So that's going to be what then? That's the 12 number, right?
12.0.
12.0, okay? 12.0,
Significant digits.
Okay.
comma.
It goes in this too in the computer, so
And if you just put in a 12, it'll take that too. No, magnitudes are always positive. Because the magnitude is just the length of the vector. The direction comes with the angle. So now the direction of the scooter's velocity is how many degrees north of east? Is it 6.18?
No,
No, what is it?
no, it's not.
You have to add it.
Ah, okay, right, because remember,
There you go.
that was how far it was south of west, right? That was that little angle over there. I've got to add that 180 to it though, right? So it's 186.18, so rounded to, you tell me how far to round this back. 186.18, blah, blah, blah. Where do I,
Wait, are we only supposed to go 360?
we do, so where do I have to round it to? 186. Okay, make sense?
Wrong.
Yeah.
40 points? That's a big problem.
It is. That's 40 out of 100 on that assignment.
Good.
Okay, make sense?
Yeah.
Okay, good.
Now we go.
Are we gonna do another one?
Can we
No.
work on it?
Okay.
Raise your hand if you're done with the assignments. Everybody done?
Brendan, how you
Brayden?
Okay, I was planning on starting new stuff, but would you rather do that on Monday while it's fresh in your mind, just do this instead? Okay, go. That's fine.
Yeah.
Sorry.